For right now, Kw is equal to 1 times 10 to the minus 14. All right? That will remain constant. That is just what this represents is the product of any hydrogen and any hydroxide that comes from water alone, just from the autoionization of water. That doesn't count anything else you've brought in. This is just for water. Okay? That means if you're going to multiply these two things together and always get the same number, if this gets bigger, this has to get smaller. Otherwise, you won't be able to keep the same number, and vice versa. If this gets bigger, that would have to get smaller in order for you to maintain the same answer when you multiply them together. Okay? So that's what we're looking at here. That means these are inversely proportional. That means when one goes up, the other one has to go down. Okay? All right. So, now we're going to look at acidic and basic solutions in terms of number measurement. If you have a neutral solution, meaning what that means is you have an equivalent amount of hydrogen and hydroxide ions. They're balancing each other out. That's a neutral solution. So that means each one of those concentrations have to be 1 times 10 to the minus 7, right? Because when you multiply them together, you got to keep 1 times 10 to the minus 14. If you're going to have a neutral solution, this is going to be the concentration of your hydrogen and hydroxide due to water. Okay? Remember, neutral on the pH scale is 7, right? So there's why. So this is the reference to that. Okay. In an acidic solution, you would expect to have a higher amount of hydrogen present. That makes sense. So what would happen is this number, if you were looking at it and measuring it, would be something greater than 1 times 10 to the minus 7. So by default, what must be true is that whatever hydroxide is present must be less than 1 times 10 to the minus 7, right? Okay, in a basic solution, the opposite would be true. The hydrogen is going to be less than 1 times 10 to the minus 7. The hydroxide is going to have to be greater than that. Since it's a basic solution, that means hydroxide ions are present in greater amount. Okay, so this looks complicated, but it's not. Okay, because all you got to realize is that whenever you multiply these together, you have to keep your Kw, your ion product for water. It's got to be 1 times 10 to the minus 14. All right, so the question says determine the hydrogen concentration, hydrogen ion concentration, for a 0.00020 molar barium hydroxide solution, and determine whether the solution is acidic, basic, or neutral. Now you can look at the fact that it's barium hydroxide and say, well, it's a hydroxide, it's got to be basic. Okay? And if I would have had H2SO4, it would have been sulfuric acid, you could have said, well, that's acidic. But now I want quantitative data showing me why or how. That means you've got to show me numbers that prove that it's acidic or basic, not just general theory, because the general theory is based upon these numbers. So you've got to show me the numbers now. All right, if you have barium hydroxide and you put it in something and it falls apart, realize that this is what's happening, right? You've got a barium ion, and there's 2 hydroxide ions present that will separate out and go into with your water. Now what you got to realize is that already, before you put this barium hydroxide in, there was water present. There was a certain amount of hydrogen and a certain amount of hydroxide just due to the water. We're going to assume that it was neutral water when you started, and it's going to be 1 times 10 to the minus 7 of each of those. So when you put in the barium hydroxide, which one of those 2 levels are you affecting? Are you affecting the hydrogen levels, or are you affecting the hydroxide levels? This is an easy answer, right? You're obviously affecting the hydroxide levels. You're putting more of it in there. So you're tipping that balance, right? All right, so what we got to do is keep track of how much hydroxide we're putting in. Here we're putting in, we got 1 mole of barium hydroxide would give us 1 mole of barium ions, 2 moles of hydroxide ions when this falls apart. Okay? Therefore, to get my concentration of hydroxide, remember what I said, we've already talked about this. If I have this concentration of this solution, we're going to have the same, since this is one of these and 2 of those, I've got to double that, right? Double that concentration to tell me how many actual concentration of hydroxide ions I have. So that's why this 2 is right here. I'm going to double this concentration because this all fell apart. And in terms of hydroxide, there's my answer, right? 0.00040 molar. In other words, 4 times 10 to the minus 4 molar. That's my concentration of hydroxide ions that I've got in there now. All right, here's what I know to be true. I asked for the hydrogen ion concentration. Even though I gave you the formula of the compound in question is a hydroxide ions. How are you going to get the hydrogen ions that formed in the water from the fact that you just added hydroxide ions? How does all that work? Well, it's this. Just remember that Kw has to equal not only 1 times 10 to the minus 14, but what it represents is whatever that H is times the hydroxide, those concentrations. So that means that if I'm solving for this, I know this, and I know this. I just got to rearrange my variables. Okay? So what is the hydrogen concentration? It is whatever Kw is divided by the hydroxide when I pull that over here. So I've got 1 times 10 to the minus 14. I've got 4 times 10 to the minus 4 for my concentration there, and it's just a simple division problem. My answer is 2.5 times 10 to the minus 11. Let's compare. Why is this a basic solution? Okay? It says whether it's acidic, basic, or neutral. I'm telling you that it's basic. Now you follow my reasoning as to why. Look at the concentration of hydroxide ions. You see that? It's 4 times 10 to the minus 4. Is that more or less than 1 times 10 to the minus 7? What you want to look at is not this number, but the exponent. Which is bigger, a minus 4 or a minus 7? Minus 4. So this is bigger, right? What this means is you have more hydroxides present than what you would have in a neutral solution. Okay? Now let's look down here at the hydrogens. Minus 11. Is that more or less than what you would have in a neutral solution? Much less, right? So if you have more hydroxides than what you would have in a neutral solution, less hydrogens, in which case? I don't understand your question.
Okay,
Yes.
you said that water will only equal 10 to the negative 14.
That's right.
How come it's
Well, first of all, what we've got to conceptually understand is that these hydroxide ions are not, they're above and beyond what the water had by itself. You're introducing hydroxide ions from an external source. Now, if we were looking at water itself, the autoionization of water, any hydrogen and any hydroxide, the product of those, if those ions came directly from the water molecules present, then they have to always be equal. They have to always equal that times 10 to the minus 14. I don't know if that answers your question, but I guess I don't. Yeah, I'm trying to think through. You've added, well, I guess the bottom line is, you've added to that proportion. If you could still keep track of the amount of hydroxides and the amount of hydrogens that were in proportion to one another from the water alone, you would retain that proportion. But the problem is you have tipped that balance. You've brought in hydroxide ions from an external source. That is no way you're not going to be able to preserve that proportion.
Really